Hey everybody, so today we're going to be talking about the interior and exterior angles of regular polygons. But before we do that, I just want to make sure that we remember the names from yesterday. So if you need to screenshot this or make sure that you have this in your notes somewhere, because as we do these problems, so if I say octagon, for example, you need to know that it's 8 sides. Nonagon, you need to know that it's 9 sides. So make sure that you have this handy if you don't know them already. There are names for things above 12 sides, but we usually just say a 13 gon or a 25 gon or a 37 gon. So you don't have to know the names past this, but they do exist. Okay, so make sure you've got that. And I am now going to switch over to my camera. Hopefully it's still, okay, perfect. It's still going. All right, so here's what we're kind of going to take a look at today. What if, let's just start with a triangle, right? A nice, easy, we know all about triangles. Let's say I had a triangle and it just so happened to be one that had angles as follows. Let's say this one's 100. Let's say this one's 30 and this one's 50, okay? So obviously not drawn to scale. So what I want to take a look at today is what happens when you start investigating the exterior angles of these shapes. So remember how to create an exterior angle. We did this with triangles a couple chapters ago. All you do is take one side and extend it. And what you have now created, this new angle, we refer to as an exterior angle. All right, and you can do this. I'm going to keep doing it at each vertex. Okay, so I have created for myself these new angles. I'll just label them angle 1, angle 2, angle 3. All right, so the deal with exterior angles is that they have to form a linear pair with the angle on the inside. So in other words, the two, remember, that just means that they are adjacent and they form a straight line together. Okay, so every triangle would have 3 exterior angles, a quadrilateral would have 4, a pentagon would have 5, and so on and so on and so on. Okay, so let's investigate this. I gave you some angle measurements. Let's see what the measure of angles 1, 2, and 3 would be in this circumstance. Okay, let me grab another color marker. So if these two have to add to be 180, because they're a linear pair, if that's 50, that means this one would have to be 130. Okay, fine. Over here, obviously not drawn to scale, but if that's 100 and these have to add up to be 180, that means this one would have to be 80. And then for my last one, if that one's 30, that means that this one would have to be 150. Okay, so I know what you're thinking, like, all right, so big deal. Well, watch this. What if I took Mr. Calculator and I added those 3 values together? Any guesses what it's going to add up to be? The 3 exterior angles of this triangle added to be 360. That's weird. Or is it? Let's try another shape. What if you had, let's step it up to a quadrilateral. So if I just draw any old thing with 4 sides, it doesn't even really matter what it looks like. And I'm going to give you the angles here again. Let's say that this one's 90. Maybe this one's 80. Maybe this one is, oh, I don't know, 140. And I do actually have to figure out what that last one is because I can't just make it up because they do have to add up. It is a quadrilateral, so all 4 angles on the inside have to add to be 360, right? So let's see, that would leave that 4th one to be 50. Okay, so now if I kind of played the same game and I just drew an exterior angle, 1 at each vertex, let's see what I get. So this one would just go straight out. That one would be another 90-degree angle, right? Because if that one's 90, that one's 90. This one, if that's 80, this would be 100. Straight out, if that one's 140, that means this would be 40. And then straight out, if that's 50, that's 130. Right? Right. Okay. Let's add these four together and let's see what happens. All right, let's see. So I had 90, 100, 40, and 130. Nuh-uh. What? What? This can't be. This can't be. Let's try a hexagon. Let's jump and we'll try a six-sided figure. Okay. I don't know. Should I just make them all the same or hold on. Yeah, why not? Okay, so let's assume that this is a regular hexagon. We're going to find out in a few minutes that it just so happens, because remember, in a regular polygon, that means that all angles and all sides are the same measure. So they all end up being 120. So every single angle is 120. So that means every single exterior angle is going to be the same also, right? Because if every interior angle is the same, that means every exterior angle is the same. So when I draw all of these exterior angles, there we go. They're each going to be 60 in this case, aren't they? Because if that's 120, this would have to be 60 to add up to be 180. So if I do 60 all the way around, tell me this. I have 1, 2, 3, 4, 5, 6, right? One at each vertex. 6 times 60 is 360. Get out. No way. Way. Okay, so let me explain what's going on here. No matter how many sides your polygon has, could have 3 sides, 4 sides, 6 sides. It could have 100 sides. It doesn't matter. And it also doesn't matter if it's a regular polygon or not. So like this one was not regular at all. This one was. Here's the deal. The exterior angles of any polygon are always going to add to be 360. What? So here's sort of a simplified way to think about it. If you imagine each of these shapes as like a track that you could actually walk on. So if you started right here, right at this vertex, and you walked here, 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 all the way back to the beginning, you basically made one full revolution, right? You went all the way around and you came back to the beginning. Same thing here, right? If you started here and you walked, and you just kept turning, turn, eventually you'd be right back to where you started. You made a full revolution. Well, think about how many degrees are in a full circle, right? If you go completely around, didn't you go 360 degrees? So it doesn't matter how many little tiny turns you took along the way. Here you made 6 little turns, right? Instead of 3 turns like you did with the triangle. If you had 100-sided figure, it would just be 100 of those little tiny turns. And eventually you'd get right back to the beginning. So this is sort of our first really, really big, super important takeaway for today, is that the sum of all exterior angles, and again, we are only doing one exterior angle at a vertex, okay? You're never going to be drawing 2 of them, so I'll even add 1 at each vertex. The sum of all exterior angles of any polygon is 360. That's so cool. And it's so nice because it doesn't matter how many sides you have. You could have 3, you could have 100. If you add them all together, you're always going to get right back to 360. That's so neat. Okay, so because we know this, that actually kind of makes the rest of this sort of easier. So let's focus the rest of this conversation. I want to focus specifically on regular polygons. Okay, this is true for any polygon, but if you happen to have a regular polygon like we did right here, then all of your exterior angles are going to be the same. So it's actually really easy to figure out what the measure of one exterior angle is going to be for a regular polygon. For a non-regular polygon like this one, it would depend, right? Because each angle is different, so there wouldn't be one set way. But if all of the interior angles are the same, that means all of the exterior angles will be the same as well. So let's talk about that. So how to find the measure of one exterior angle of a regular polygon. It's got to be regular. Otherwise, you cannot do this. All right, so first, you are going to divide 360 degrees by the number of sides. And literally, that's it. That's it. That's my one step. I'm just, because it's always going to add to be 360. So if I know that they're all going to be the same, and I know I'm just going to draw one at each vertex. So if I have a decagon, for example, has 10 sides. So I'm so sorry. I thought that this was on silent. So a decagon has 10 sides. So if I want to find the measure of one exterior angle, I'm just going to do 360 divided by 10. And I'm done. That's my answer. That's so cool. So, example, measure of one exterior angle of a regular decagon. So, you need to know how many, so again, when I say decagon, it's up to you to know how many sides that is. So I'm not going to come out and tell you. So decagons are 10-sided figures. So literally all I have to do is 360 divided by 10, and I get 36. That means if I have a regular decagon, every single exterior angle is going to be 36 degrees. What? That's so cool. I know. Let's do another example. Measure of one exterior angle of a pentagon. So you need to know, oh, pentagon, that's just 5 sides. So all I have to do is 360 divided by 5, and that's, I believe, 72, right? Yes. So I get 72 degrees for the measure of one exterior of a regular pentagon. Oops, I forgot regular in there. You have to have that. All right, so, well, that's super easy. Well, it is. And then I'm going to sort of expand on this. What happens when I want to know the measure of one of the angles inside the polygon? I know it seems weird that we started outside and now we're going to talk about the inside, but it's actually easier to do the outside stuff first, because if you have that answer, you can find the inside answer really easily. So let me use this pentagon as an example, because I can actually, pentagon only has 5 sides, so I can roughly draw one. That's pretty good. Okay, so there's my regular pentagon. So remember, that means all 5 sides are the same, and all 5 angles are also going to be the same. So here's what I just figured out. If I draw an exterior angle, this exterior angle is 72 degrees. I just did the math to find that out. Well, now I'm going to be asking you, well, what's the measure of one interior angle? Well, if you have this number, finding the interior angle is super easy, because again, remember, these have to add up to be 180. So if I already know this one, couldn't I just subtract it from 180 to find the measure of the inside? Exactly. Okay, so in this case, that's just what, 108? Yes. So I would find 108 degrees for the interior. So let's just write that out in steps, how we do that. So to find the measure of an interior angle of a regular polygon. Still has to be regular, right? All I'm going to do is take the measure of one exterior angle and subtract it from 180. Take measure of exterior angle and subtract from 180. That's it, right? So if I have the exterior, I can find the interior super easily. Okay, so let's do another example. Let's say I want, so the instructions will say something like this: find the measure of an interior angle of a, let's do a nonagon. Okay, so you're going to look, make sure that you are paying attention to whether it says interior or exterior, because that's going to change your answer completely, right? So to find the measure of the interior angle, our directions say, take the measure of the exterior angle. So I got to start with that. So remember how you find that. You just do 360 divided by how many sides you have. So I have a nonagon. How many sides does a nonagon have? If you said 9, you are correct. So I'm going to do 360 divided by 9, which is 40. Oh, yes, just kidding. 40. Okay, so let me just note that's the measure of exterior angle. And now I'm going to take that number and subtract it from 180. So I do have this additional step. So now 180 minus 40 equals 140 degrees would be the measure of an interior angle. Did my camera freeze? Oh, for the love. Sorry. Let me just restart this. Can never escape these tech problems. Okay. Come in. There we go. All right, so we had found the exterior angle, just 360 divided by the number of sides, get our answer. And now you're going to take 180 and subtract whatever that answer was. So for the measure of the interior angle, it's just going to be 140. That's so cool. I know. All right, and then there is one last skill that we need to talk about today, and that is finding the sum of the interior angles for the whole shape. Okay, but again, it's really, if you have these numbers, you get this next answer super easy. So you already know some of them. When I say the sum of the interior angles, that's taking all the angles inside the shape and adding them together, right? So for a triangle, for example, you already know that the 3 angles add to be 180. You know this. You've known this forever. For a quadrilateral, a 4-sided figure, you know that those 4 angles always add to be 360. Always. So now what happens with a 5-sided figure, with a 6-sided figure, a 7-sided figure? It does keep going up by 180 every time. But that would be really annoying for you to try and figure out, like, what if I asked you about the 12th, a 12-sided figure? You don't want to start at, okay, well, I know a 4-sided figure is 360, so let me keep adding 180 until I get up to 12 sides. That would take you way too long, and it would be kind of messy. So, of course, there's a shorter way. And if you already have these numbers, getting that number is super, super fast. So let's kind of go through the steps of how to do that. So I'm going to turn the page here. And so for this last skill, we are going to say to find the sum of all the interior angles of, and this does apply to any polygon. It doesn't have to be a regular polygon, but I'm going to use the regular polygons to get my answer, if that makes any sense. So I'm going to say to find the sum of all the interior angles of, and I'm going to say any polygon, because it does work for any of them. I just use a sneaky way to get there. So there is a formula for this, but I find that it's not that helpful, especially because it's very easy to know that all the exterior angles add up to be 360, because that's true for any polygon. You don't have to remember a different situation for each one, right? So they all add up to be 360. And so if I find the measure of an exterior angle, super easy to find the measure of an interior angle, right? Well, once you have the measure of one interior angle, couldn't you just multiply by how many angles you have? And then there's your answer. That's pretty much what we're going to do. So step one, find the measure of an exterior angle. Which, remember, is just 360 divided by number of sides. That's all you're doing to find that. Very easy. And then in the second step, you're going to find the measure of an interior angle by doing 180 minus the answer from step one. And then, so once you have the measure of that one interior angle, now you're just going to multiply by the number of sides you have, and you're done. Multiply that answer by the number of sides. That's it. And then you have the sum of all of the interior angles of any polygon. So let's start by doing one that we know. I know that the three angles in a triangle add up to be 180. So I already know the answer to this, but let's pretend that I didn't. Let's go through these steps and just make sure that it actually does work. Okay, so find the sum. Oh, let's put the D on sum. Find the sum of the interior angles of a triangle. Again, obviously in real life, you would never do this because you already know the answer is 180, but pretend you didn't. All right, so step one says find the measure of an exterior angle by doing 360 divided by the number of sides. So in this case, that would be 360 divided by 3, which means I get 120 for an exterior angle. Then I go ahead and find the interior angle by taking that answer and subtracting it from 180. So 180 minus 120 gets me 60. There's an interior angle. That's one interior angle. Now, if I want the sum of all of them together, I just have to do 60 times however many sides I have. Since it's a triangle, of course, I have 3 sides. So I'm just going to do 60 times 3. And lo and behold, let's see if I can fit this in here. 60 times 3, 180. So there's the sum of all of the interior angles. Okay, I can't tell you how many times kids get things wrong because when they're asking for the measure of one interior angle, they give the sum or the other way around. So make sure that you are reading whatever the question is very carefully. If they want the sum of them all, it's going to be a big number, and you're going to go through all three of these steps. If they want just the interior, only do the first two steps and then you're done. Okay, let's try one that we don't know. Find sum of interior angles of a, I don't know, what do you want to do? Heptagon, how about that one? Heptagon. Heptagon. So you need to know that a heptagon has 7 sides, right? So step 1 says do 360 divided by 7, which means my exterior angle is 51.43. Okay, they're not always going to come out nice, and that's all right. So step 2, so that's the exterior. If I was asked for the exterior, I'd have it. To find the interior, I just do 180 minus that number. So that's just going to get me 128.587. Just kidding. 128.57. There's my interior. And then if I want to find the sum of all of them, which is what I want, I'm just going to take that answer and I'm going to multiply it by 7 because there's 7 sides or 7 angles, right? So times it by 7 and I get 900. So let's just squeeze it in down here. 128.57 times 7. Oh gosh, sorry. I had 9 in my head because the answer is 900. Times 7, because there's 7 sides in a heptagon, which means there's 7 angles, 900. So the answer to this particular question is 900. So always make sure that you are answering the right, of course my camera froze, but I'm pretty much done. So just make sure that you're answering the question that they ask, because they could only be asking for the exterior angle, or they could only be asking for the interior angle, or they could be asking for the sum of the whole thing. All right, so make sure that you answer the correct one of those 3 that they ask. So your homework is actually going to be on CUDA, and I believe it is already live. Hang on well, I'm going to set it to be live, but I'm going to look at it right now and here we go. So I'll just do a couple of these with anyone that is having a little bit of trouble. So let me just log in right here real quick. Just like I'm there in real life, huh? So weird. Okay. Cancel. Oh, that's not what I wanted to do. Just kidding. Stop the share. I want to share the screen from here. All right. Okay, so you're going to get these, and just again, I cannot stress this enough, just make sure that you are reading the directions. This one says they want the measure of one exterior angle. So according to our notes, to find that, so remember, an exterior angle is just one of these. Okay, all I need to do is 360 divided by the number of sides that I have. This shape is an octagon. 1, 2, 3, 4, 5, 6, 7, 8 sides. So make sure that you do 360 divided by 8. And when I do that, I find out that the answer is 45. Okay, so got that answer pretty easily. And that's all I do for the exterior angle ones. This one you already know. That's super easy. So just do 360 divided by the number of sides. Now, eventually you're going to hit ones where they don't give you a picture. They just give you the words. So here you've got just the 14 gone. So all I have to do is 360 divided by 14, because a 14 gun would have 14 sides, right? So that's all I'm doing there. Looks like you're going to round to the nearest tenth, so be careful. And then you will eventually get to ones where the directions switch. So make sure that you're watching. Look, it has changed. Now it wants the measure of one interior angle. Okay, so according to our notes, we got that by first finding that exterior angle and then subtracting it from 180. Because remember, the exterior angle and the interior angle are supplementary because they form that linear pair, right? So for this one, I have 6 sides. So I'll start by doing 360 divided by 6, which is just 60, right? So that's the measure of the exterior angle. That's what I just found. They don't want that. They want the interior. So remember, to get that, I'm just going to do 180 minus 60. That's how I land on 120 from this. Okay, so for this level, you're doing 180 minus the answer that you just got. So that is how I arrive at my answer of 120. Okay, so that's how you do it for this whole section. Find the exterior first and then go ahead and find the interior. And again, eventually, they're just going to give you words instead of the diagram. So for example, this one real quick, I would do 360 divided by 16, and I get 22.5. And then to find my final answer, I'm just going to take 180 and subtract from it that 22.5. So I will let you do that. I'm not going to do all your homework for you, but that's the gist on those. And then eventually you are going to reach the ones that ask for the interior angle sum. So you really got to watch because it's going to switch on you. This one, you already know. You know what those angles add up to be, so you don't even have to do the math. At least I hope you know what this adds up to be. If you don't, you could do the math, right? So let's assume you get to this one. You don't know what the answer is. So let's go through the 3 steps for this one. First of all, I can't do anything until I know how many sides I have. I recommend that you always start by counting the bottom thing first. So then as you're going around, you don't forget like, ooh, did I count that one or did I not? Come up with a way to, so if you always start by counting the bottom one first, then you know when you get back around, you already counted it. All right, just get into the habit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If you can mark it, it's always easier too. But anyway, so this is a nonagon, 9 sides. 9 sides, just so we don't forget. I don't know. So let's find an exterior angle. 360 divided by 9. That's going to be 40. So there's my exterior angle. Now let me find the interior angle. I would just do 180 minus that exterior angle. So that leaves me with 140 for an interior angle. But now I want the sum of all of them. There's 9 of them, right? Look at them all. 1, 2, 3, 4, all the way around. 9 angles that all measure 140. So I'm going to do 140 times 9. And that is 1260. And there's my answer for the sum of all interior angles. Okay, so I hope that this makes sense. Okay. I would say any questions, but I'm not there to answer them right now. Feel free to shoot me an email though, and I will get back to you. But yes, hopefully this will make sense. This homework should be live for you now, so feel free to go ahead and do this. If you finish and you still have time, you know you should go back and work on any stuff that you owe. And don't forget about the extra credit that is still there. So you have plenty of stuff to fill your time, okay? All right. Thanks, guys. Have a great weekend.